So in previous lecture we learned how this F average, which is the impulsive force which is coming because of this liquid is going out, velocity of efflux, is responsible for changing the friction force here. We did two cases, one corresponding to motion happening. In that case the friction was kinetic in nature, and the second corresponding to motion not happening. In that case the F average was equivalent to Fs. Now we want to check, because there are some conditions under which this F average might cause the toppling also. You see what is happening in this case. In this case, when the F average is acting and if normal, in the previous lecture if you remember we applied the normal at this location. So and generally we apply the normal passing through the center of mass. We generally assume that normal is passing through center of mass. Okay. So in that case, if we assume that still normal is passing through the center of mass, and if we calculate the torque about this point, so if I calculate the torque about this point, assuming normal is still passing through center of mass, then mg is passing through this point, normal will pass through this point, and F, friction force, is also passing through this point. This is a point which is the intersection point for three forces. So all three forces, the torque because of all three forces about this point will be 0. Okay, and there is this fourth force F average, and because of this fourth force, this force will provide some non-zero torque about this location. You see, force multiplied with perpendicular distance. So if I calculate the net torque about this point, that net torque is about to be non-zero. So that might cause the toppling, which we don't see actually. And that net torque will come whether this is small or this is large. Even the moment we find this force, and at that moment if the normal is still passing through mg, that small force will create the toppling, which we don't find. So basically something is happening. And that something is the shifting of normal action. The thing is, what happens the moment F average is coming into nature, the impulsive force start acting onto this vessel, the normal starts shifting. It starts shifting, you see, and that starts shifting towards left. In this direction, it starts shifting. So in that case, if I calculate the torque about this point, mg and friction will have 0 torque, F average will have clockwise torque, and this normal reaction will be having anti-clockwise torque. This normal action will be having clockwise torque, and this F average will be having anti-clockwise torque. So torque created by F average will be nullified by the torque created by the normal reaction. Let's study this. So let's assume this normal has shifted by a distance x. X is the distance. And we know, let's assume this is radius capital R. The vessel is having radius capital R. The normal is shifted by distance x. And if we make the FVD, normal will be equals to capital mg, because this system cannot move up or down. So I can directly write n is equals to capital mg. The magnitude of normal cannot change. So let's apply the torque. Let's calculate the torque about this point. If I calculate, I'm calling this point as P, we can say. So if I calculate the torque about point P, that torque about point P will be equals to F average multiplied with capital H minus small h, which is this. This is capital H. And this value is anti-clockwise. And there will be torque coming because of normal reaction and multiplied with x. Normal reaction multiplied with perpendicular distance. And this will be clockwise. And if the system is not toppling, in that case torque should be 0. So that gave us that F average multiplied with capital H minus small h is equals to n times of x. We can put the value of F average along with the normal reaction. If you remember, the value of F average was 2 rho g a multiplied with small h. And that will be multiplied with this value, capital H minus small h. And that will be equals to normal reaction, which is equals to mg multiplied with x. And that will give us the value of x as 2 rho g a small h, capital H minus small h, divided by capital mg. That's the value of x. So you see, in this case, if I keep changing the value of small h or small a, these are the two variables, or basically the first one variable is a small h. If I keep changing the value of h, this numerator will keep changing, and if the numerator will keep changing, x will keep changing. But there is a condition regarding x. This x can change till r only. It cannot go beyond r. The normal action cannot go beyond the vessel. It will remain inside the vessel. So till x value is less than or equals to capital R, this vessel will not topple. The toppling will not be happening in that case. But the moment x will become r, or it will become more than r, the toppling will happen. And for that, h will be changing. So we can calculate the condition regarding the toppling. And the variable here, there is this one variable which is dependent variable, and there is this one variable which is the independent variable, that is the small h. If I keep changing the value of h, we might find a position corresponding to which this body might topple. So, at the time of toppling, the value of x, just before toppling, value of x will become capital R, which is the radius in this case, not the range. So at the time of toppling, x will become R, and this right hand side value will be little bit more than R. So this 2 rho g a h, capital H minus small h, divided by capital mg will be slightly more than the value of capital R. And if that condition is there, the body is going to topple, because at that condition, normal will be at its max, and that will be farthest from the center of mass, and that will be at this corner. So when the normal will be reaching at this corner, there will be a sufficient condition for the toppling. So this is the condition, and in this condition, if you put the values, you will get h, capital H minus h, that will be greater than R, capital Mg, divided by 2 rho g a. That becomes, this is a quadratic equation. Obviously, you have to solve this equation. Examiner will be giving you the value of h, and he will be asking you whether this body will be toppling or not. Ultimately, you have to put this value in this equation. If you put this value in this equation, you will be getting that condition. Okay. So, as you can see, since we were changing the location, corresponding to the change in location, VE was changing, range was changing, F average was changing, and now the toppling condition is also changing. As we keep changing the value of h, as we keep changing the location of hole, the normal reaction starts shifting. It can shift till this point. And the moment normal reaction will be reaching at this point, and if you further increase or decrease, somehow if you increase the F average, this body is going to topple. Okay? And in that case, this is a condition which will follow.